This is a video that is for helping students understand how to go through an experiment that we have in our Elementary Astronomy Lab. This experiment's offered online. It's also offered to students in the classroom. So in the classroom you have a teaching assistant, but here on the web you may need a little extra help to understand how to use the software. So this is an attempt to get you started in that direction. For those of you who are in the class, you have access to an online forum where we can discuss specific issues, and I can add to this video as requested there too. So this one shows the class running here in the fall of 2016, and it may change a little bit from semester to semester, but it should be about the same. Just click on Jupiter satellites under this entry, and that opens up the discussion about what to do. There are other issues here, a discussion forum, a place to answer the questions where we record the grades, which you would do later down here. So keep a notepad around so you can write the answers down. You would enter those down here when you're done. Just click on Jupiter satellites, and it opens up the discussion about why they're interesting to us and what we know about them, who saw them first, and it's the usual content, how our telescopes work to get the images that you'll be looking at. And all of that you should read and study and try to understand before you begin to answer the questions which are the basis of this experiment. So we're going to try to measure some images of Jupiter, and here's an image which is an example of the sort of thing you might deal with if you were seeing everything that is there. This is Jupiter with its belts and zones. It's tipped on its axis as it appears in this image, but we don't really know the orientation of the camera either when the image was taken. Here on the left side, that's one of the satellites of Jupiter. It's actually Callisto, just beginning to cross across the face of Jupiter. And if you look really carefully, you'll see a shadow underneath it, where the shadow of that satellite is being cast on the upper clouds of Jupiter. So as the satellite moves in orbit around Jupiter, it will actually traverse across the image, and we'll see that shadow move as well. And we could follow that and measure the orbit of the satellite by just following its image after one exposure after another. It's a little more obvious, though, when the satellite is not on top of Jupiter, but off to the side, and that's where all of the images that you'll work with are taken. So here's an example of that, and you see each of these bright dots is one of the 4 bright Galilean satellites, and we can zoom in up close with the software that we're going to show you how to use. You can settle in and look at any one individual satellite and measure it exactly. So the software has 3 major panels. One of them shows the image itself. That'll be like this one. Another one shows a magnified view of that image underneath the cursor. So as I move the cursor around, and here the cursor is right there, you'll see what's underneath it in greater detail. That's right here. And then this one shows you which part of the entire image you're looking at in the lower panel. Then there are some values up here in this corner that tell you how much light has been detected underneath that cursor. Here it's 253 units, and you don't have to be concerned about what that actually measures. It's just the bigger the number, the more the light. And where it is in the image. This says it's at location 346. That's actually measured in pixels across from the left edge across, and 49, which is in pixels up and down. So each of these images was taken at a given time, a date and a time, and the exposures are relatively short, so it's as if this captures the appearance of Jupiter at that particular time. The times are recorded by a timestamp, which is a number of seconds as a reference time, and you may need to convert that timestamp to an actual date and time. We have a link to a converter which lets you do that. We'll come back to that specific one before we're done with this little video. And then you can figure out which satellite is which using a model for Jupiter's satellites, which was provided by Sky and Telescope magazine. Just click this link and the model comes up. And then You can insert a date and time. By default, it's the current date and time, and it'll show you how Jupiter looks at this very moment. You can change that entry, so if we want to see what it looked like in 2010, but on the same date and at the same universal time, click recalculate and watch the satellites move. Even just changing the time by a small amount, let's say like 2 hours, so instead of 04, we'll go to 06, watch the satellites move in just 2 hours. You can see them move past one another. These things go around Jupiter in just a matter of days, and it means that from hour to hour you can follow their motion. From day to day you'll see big changes, and in fact the changes from day to day can be so large that it's hard to figure out which satellite is which on the next day after you've seen them the day before, and that's why this is very helpful to help you track them. The little simulator has a letter above each satellite which codes you which one it is. I is for Io, or some people would say Eo. E is for Europa, C is for Callisto, and G is for Ganymede. So we go back to the class website, and you'll find toward the bottom of this activity a set of questions, which are the ones which are required to answer to get credit for doing the work. So they help you guide you through conceptually what we're trying to help you learn about here. And the very first question is fundamental, but it's one you would probably want to ask yourself if you were just doing this without any guidance at all. And then it's which one is the brightest one, and you might even want to know why are they brighter. But the starting point is which satellite is brightest in this image. So this question refers to a particular image. It's the one that's time-stamped 12864-27002. So just sort of hold that number in your mind. We'll go back here and turn on the access to the images, which the link for that is up here near the beginning. You click that link and you will see this website appear. It's just like the snapshot that appears on the description webpage, but it's live. And at the top of that, there are some links which will load specific images. Click on one of these links and that image shows up. So like this one, and you see suddenly that image shows up here. There's the whole view of it here. This, if I zoom in a little bit, say 2, then I see a smaller part of that image, but I can move this around and see the whole thing. And then up here is what is underneath the cursor here. So if that's that satellite, Jupiter itself, and that one. So to figure out which satellite we're looking at, we have to convert these times using a time converter, and we have to identify the satellites using that link. You can actually work in this page and have access to those other links. If you want to make them show up in a separate window, you can just right-click with most browsers, and it will give you the option to open link in new window, which will let you have it off to the side, and then you can use it while you're working on this website. So I'm just going to show you this one, which is the one that was asked about, and here it comes. And if we look at the whole image, you can see that in this particular one, which is why it was chosen really, you can see all 4 satellites really clearly, and they're very different in brightness. So the question is which one is brighter, and you can look at this image and just say, well, it's got to be that one because it shows up better. We can measure that and make it quantitative though, so just by putting the mouse right over it, notice how up here you can see just where you're looking, and right here you can see the value. So maybe that's not enough detail, and you might want to zoom in a little bit to see it better. So go down to say zoom 4 and move the panner over like that. And now you can measure each satellite very precisely. So there we go. We'll just put the cursor right over that single pixel, and it has 94 units in it. This satellite has less light, 152. Go over here. That one has 130, and there's one hidden in the darkness over here, and that one has 103. So now you can tell right away, and in a quantitative way, that this satellite is the brightest satellite. So there's the answer. Well, except you have to figure out which satellite that is. So to do that, you have to convert the Unix time and then identify the satellite. So to convert the Unix time, you take a note of that number, 12864-27002, and then you click this link. Now I'm just going to do that. Then you would insert that number here, click submit. The date and time will show up here. With that date and time, you go back to the model and insert that date and time here and press recalculate, and you'll see the satellites identified. And now you know the one off on the far left of the one of that particular image is the one that you want. You pick that one out, and that's the answer to the question. The next question was which satellite is closest to Jupiter in this image, and of course that's not too hard either, because when we looked at those images, you remember it was pretty clear. One of them was right next to the planet. And again, you just have to identify that, but once you've got this model set up, you can do that real quickly. Now, also in that model, you now know which one is Europa, as well as which one is each of the other satellites. And this just asks, how many pixels separate Europa from the center of Jupiter? And the reason for asking this is that that's the key to what we're going to try to do later, which is to figure out the orbit of a satellite. So you want to measure where the center of Jupiter is and where the bright dot that is Europa is, and then you take the difference between those two numbers to get the separation. We're just worried about left to right for the most part, since the satellites are moving primarily left to right in these two, in the images from night to night. So that gets you started, and then from here on, you can follow the discussion and try to answer the other questions. We will follow up with another video if you raise some more questions over on the class forum.